Welcome to Percentiles. I trust you've watched the empirical video so you're comfortable with the empirical rule. Then these numbers should kind of make sense to you. We were looking at IQ tests where the mean's 100 and standard deviation might be 10. If we were in the 50th percentile, that would mean 50% of the population had IQs less than we did. And so 100 is the 50th percentile in our chart. If I wanted to decide what the 16th percentile was, well, if I added up 0.15% plus 2.35% plus 13.5%, oh my gosh, that magically comes out to 16%. Therefore, 90, the horizontal coordinate, is the 16th percentile. If we were to make a chart of percentiles, we would say the 100 was the 50th percentile, the 90 was the 16th percentile, 80 is the 2.5th percentile, and we get that because if we added the 0.15 plus the 2.35, the area to the left of 80 under the curve is 2.5%. So 80 is the 2.5th percentile. 70 is the 0.15th percentile. Now, if you recall these numbers that we had, areas under the curve in the slices from the empirical rule, if I took that 50 and I added it to this 34, the 50th percentile plus the 34 makes this the 84th percentile. The 84th percentile is the score 110. Add that 13.5 to the 84, and we have 97.5th percentile is the score of 120. 130, what's that percentile? Well, we're going to take this 97.5 and add the 2.35, and that gives us 99.85th percentile. And there we go. Let's take a problem. I made up a tire company, Rubberman Tires. They have a mean of 34,000 miles with a standard deviation at 2,500 miles. Find the probability a random tire will last no more than 31,500 miles. Well, I'd like to make out a little chart like we've been doing, but now my mean has changed to 3,000 or 34,000. If I subtract one standard deviation, 34,000 minus 2,500, that's going to put 31,500 here. Subtract 2,500 from that, and I have 29,000. Subtract 2,500 from that, we have 26,500. Go back up to that mean of 34,000, add 2,500. That puts me at 36,500. Add 2,500. The second standard deviation up from the mean is 39,000 miles on the tires. Add another 2,500, we're at 41,500. If we recall our percentiles and our percentages, we have 0.15% in that tail. We have 2.35% in this slice. We have 13.5% in the next slice. 34%, 34%, 13.5%. Maybe I should put some percentage signs here since the computer is so picky about that. Wouldn't want to set a bad example for you. 2.35% and 0.15%. So when they say, what's the probability I buy a tire and it lasts no more than 31,000 miles, I want to know what percentage of tires lie in that space. And so I'm going to add the 0.15 plus 2.35 plus 13.5. And that's going to give me an answer of 16%. That's the chance I get a tire that's a dud and doesn't last any more than 31,000 miles. What's the chance that I get a tire that lasts somewhere between 29,000 miles and 36,500 miles? So now I want to know the chance of getting tires in this interval between 29,000 and 36,500. So I'm going to add the 13.5 plus 34 plus 34. That gives me 81.5%. Good chance I'll get a tire that lasts somewhere between 29,000 and 36,500 miles. What's the chance I get a tire that lasts at least 34,000 miles? Now I want to know the probability of being in the upper half. So I'm going to add that 34% plus 13.5% plus 2.35% plus 0.15%. Or, if I'm real savvy with these graphs, I say, it's half the graph, it's 50%. The mean's always in the middle. And that works too. You got a 50% chance. Part B of this problem. Find the percentile of tires with lifespans of 26,500. Well, let's draw our picture again. I subtract 2,500, that puts me down to 31,500, 29,000, 26,500. Now we start adding 2,500 to the mean. We get 36,500, 39,000, 41,500. Let's put in our percentiles that we figured out. This first guy is the 0.15th percentile. Maybe I should put it in pink since I wrote the word percentiles there in pink. Help you out a little bit. This is going to be the 2.5th percentile, which is a lifespan of 29,000 miles. 31,500 is the 16th percentile. 34,000 miles lifetime is the 50th percentile. 84th percentile. 97.5th percentile. And this last one, 99.85th percentile. So we go up to our question and they want to know, what's the percentile of a tire with a lifetime of 26,500? Well, that would be the 0.15th percentile. $31,500. That would be the 16th percentile. $34,000. That would be the 50th percentile. And the 39,000 lifespan is the 97.5th percentile. I hope this helps you with the percentile and empirical quizzes. And thank you very much. Don't hesitate to email me if you have questions.